Now we will look into momentum. Momentum is basically quantity of motion, how much quantity of motion a body possesses. For example, a truck possesses more quantity of motion than a car. Uh, a, a bullet has a more quantity of motion than anything of the same size. Uh, Momentum is represented by P, and the quantity of motion depends on mass and velocity. We know it is if you have to apply more force to drive a truck than you have to in order to drive a car because of the difference in mass. And we know why a bullet is dangerous, because although its mass is less but it has very high velocity. So the quantity of motion, the quantity of motion is dependent on mass and velocity, and momentum is the product of the mass and velocity. Mass is measured in kg, velocity is measured in meter per second. So momentum is measured in kg meter per second. And since velocity is a vector quantity, so momentum is also a vector quantity. If an object is at rest, for example, a ball of mass, let's say 5 gram, it's at rest. So its momentum will be 0 because its mass, although it is 5 divided by 1000 kilogram, but its velocity is 0 meter per second. Its velocity is 0 meter per second. But an object in motion will have some momentum. Next, we will look at momentum in terms of Newton's second law. Newton's second law tells us that F equals to ma. Now we know that acceleration is the change in velocity with respect to time. So we will plug in a in this. F equals to m v minus u over t. So F is mv minus mu divided by t. So this tells us that another definition of force is the rate of change of momentum. Rate of change in momentum. This is another definition. Now if you multiply by t on both sides, F into t, this will give you mv minus mu. Or now mv is the final momentum, mu is the initial momentum. So F times t gives you change in momentum. And F time t is also known as impulse. And this is measured in Newton second. And this basically tells us that if the force in a car crash, for example, in a car crash, if the force acts for a longer amount of time, then the change in momentum will be larger and it can be dangerous, the collision. However, if the force is acting in a much less amount of time, if the force is acting in a much less amount of time, then the change in momentum will also be less, but the change in momentum would be less. For example, you have F equals to change in momentum over time. This basically tells us that if the t increases, if the t increases, if the time of collision increases, then the force acting will be less, because this is an inverse relationship. However, if the time decreases, if the collision acts in a very small amount of time, then force will be much high. The rate of change of momentum would be larger. The force will be, if the time acts for a larger amount of, if the collision acts, change in momentum occurs over a very small amount of time, then force will be larger. However, if the change in momentum occurs over a very longer amount of time, then force is smaller. And we use these things like crumple zones, seat bags, to increase the time t over which the car collides. For example, let's say during a car collision, 50,000 Newton force acts for, let's say, zero point 0.1 second. The force, for example, a car was traveling with initial momentum, let's say 50,000 kg meter per second. Then when it crashes, it comes to rest, its momentum was 0. So change in momentum is 50,000. Time, let's say, is 0.1 second. So F is 50,000 kg meter per second divided by 0.1 second. 50,000 divided by 0.1, the force is 500,000 newtons. So this is life threatening. However, if let's say the time is, let's say 2 seconds, then the force is 25,000 newtons. So it is much less. So this basically tells us that the relationship between force and time, the impulse,